Alright, welcome back. In this video we will check out tokens. So let us go into Auth nodes. So if you remember, once we have logged in, we need to send a token to the user that has information that first of all says the user is logged in, but also like which user is it. And we'll use this Pasito RS token. Crate rather. So let's have a look at that. And I think we can do this. And Pasito RS. This one. So let's add that to our dependencies. Pasito RS. And let us simply take the newest version. And as before, let's try to write a test script to get an idea of how it works. So test, let's do test Pasito. And we'll make a main function and do the standard hello tokens. We will go here and we will run it. Test Pasito. Okay, so we got that running. And I'm going to get rid of that. Where is it? It's in lib. There's this annoying thing, patch, which we don't need right now. Yeah, so now it doesn't print so much stuff. So test Pasito. And let's see how it works. Creating and verifying public tokens. We want a local token. I forget exactly what the difference is, but yeah, we need a local token. Maybe we can see here. No, anyway, I don't remember. So what does it say here? Available and create features STD and v4 only. Okay. So creating and verifying local tokens. Let's try that. So we need some claims, and the claims is like the information that's in the token as far as I know. So we'll make a new one, and apparently that can fail, which is weird. So let's put some stuff in there. So this is super secret, and another thing you want to do is probably user. We use email. Well, let's do an ID. So that could be just a number. Okay, so now we need to encrypt it. Well, first we need to import Pasito RS claims. So we can add the stuff, and let's start simple and just print this thing. What is it complaining about here? This stuff can also fail, so I'm going to unwrap that and let's run it. Okay, so we have this claims object, and it has, like, I guess when it was made, it has the data, then it has the different things. So there's a data, which is a string, super secret. There is an expiration time, I guess, which is an hour from now. Then there is a user ID, and this one I don't know what it is. Okay, so then we need to encrypt it. So we use a symmetric key algorithm, which means it's the same key that's used for encrypting and decrypting. So we generate that key, which is interesting. very interesting. Probably we need to generate. This is probably a trait. Well, who knows? Apparently not. And we also need this v4. So who's Spacito rs local version 4. And we should unwrap it. But it's very interesting that it all kind of like can fail. So let's try to look at the key. Okay, it's a symmetric key and then it doesn't print whatever is inside it, which is interesting. That's very interesting. Can we somehow force it to tell us? Modules, claims errors, keys, symmetric key. Private fields, they really don't want to tell us. Format. Can we do this? No. Still, even pretty printing it doesn't do anything. So it has some bytes and then there's some phantom. I'm not sure what phantom data is. Okay, but we should be able to get the bytes. At least we can try that. So we can say as bytes. And this can be the key bytes. That's not possible. Okay, so there's a bunch of bytes in there, and do they change? They seem to change every time. So this is basically generating a random key. So to do, look into how this is generated. Okay, decide how you want to validate the claims. The default verifies these claims. Okay, fair enough. So there's some kind of, you can customize how things are validated. I don't mind that. So here we need the claims validation rules. And how do we create the token? So that actually happened up here, which I kind of missed. So we get the key and then we can make a token that we encrypt. It takes the key, it takes the claims, then there is none, I don't know what that is. And then there is also a sum argument. What is this for? And we unwrap that. And then let's print it. And let's do this. So I don't know why, but there's just no information available on any of this stuff in my Rust analyzer. Okay, so here's the token. It says something about what it is. It's a version 4 local token. And then there is a huge string. So I suppose that this key has to be stored. Right, we need it to decrypt as well. So we need to store it in some settings or something like that. So really, it should be read from some settings. So maybe we can check out what's here. Is there like from? It doesn't really help. But we have the symmetric here, so we can say from bytes. So if we have some bytes, yeah, this is a secret key. Now, once if we print the key again, then if we run this multiple times, it does not work. So that's interesting. So what we can do is maybe do a quick map error and then unwrap it. So it will actually tell us what went wrong. Error key. Well, that's not very informative. And we don't know what type this is. It's just an error. It's just an error. Huh. And what error is that? That is inside this crate. So it's an invalid key. So how do you make a valid key? Is the real question. Maybe it has something to do with length. That is a usual thing. So let's. This is a very long secret key. Very, very. Still not. That's interesting. So, So what are the requirements from this for this thing? Why doesn't it say that? Maybe you should just know. And if you don't know, shouldn't be using this crate. So we're back here. Okay, so what we can do is let's generate a token. Let's print the bytes and how do I convert the bytes to a string? To vec. Can I just do to string? Is that a thing? Okay, it looks like we can do std string like that. So let's get rid of that code. And now even this stuff is not working. Let's not unwrap it then. Okay, so there is some kind of error. It's not UTF-8. can we do from ASCII? Well, ASCII should be a subset, right? Maybe just from. Okay, I may have found something. Let's get rid of that. So we have the key, and that should work. We run it, print some stuff. Great. Now let's try to format it. So we need this one. Maybe we don't have that format thing. But let's, okay, it is there. So then we format this symmetric key into the string, and then we can print it to see what it looks like. Okay. So there is a bunch of crazy stuff in here. And let's run it a couple of times. We can see some of it changes. But so what if we take this? Is this gonna give me trouble now? It looks like yes. Okay. For some reason my HTMX is bothering me right now. Give me a second. Alright, so I ran it in a different terminal, and then I got this stuff out. So let's say that this is our secret that we get from the settings. Secret from settings. And now we want to create a key from that. So secret from settings and as bytes. And let's try to print that. Format it. So we run this again, and still it doesn't work. Maybe we don't need that. Oh, now it doesn't compile at all. So very strange. Maybe this method is the wrong one, because if we look here, there is this try from thing. So how about we do that? So try from secret from settings, and we unwrap that. See if that succeeds. So clear things up. So that also failed. So weird. Because we can print it out. It's because we cannot use this. We need to say we need to use this other thing. So now it works, because we needed this K4 local thing, and we can run it a couple of times. Okay, so I think we're gonna go with that. Yeah, it needs to be try from. I just changed some stuff. And now it's somehow I broke it again, because this has to be str. I just tried some stuff quickly off screen. Okay, so what you can do, I'm sure this is not the right way, but we can run this a couple of times. generate our own very secret string here, and then we store that in some settings, and we use that to generate the key. Because, as I said, we need the same key to what's it called? To decrypt things. So it has, I think it has, it was v4 local. So let's try to use the secret string from settings. And that also failed. How can that fail? How can that fail? It's not this, surely. Let's try to run it over here again. So this string, it says K4, not V4, sorry. So K4, now, okay, let's get rid of that. Now we can actually get a string from, sorry, a key from the settings. So let's go back here and have a look. Public tokens is not it. We're here in the local tokens. And then we made the token here that uses encrypt function that has a footer and an implicit assert. I have no idea what that is, so we will ignore it for now. Actually, why don't we just do none? Okay. It runs. It runs. Great. So then we have to make the validation rules, which is how we validate a token that we get in from the browser, from the user, client. And we have to say local, so now we need this local trait or type or whatever. Okay. So what does this encrypt return? It returns a string. So we get in basically the cookie, the string here, and then we turn it into an untrusted token, which does some parsing, presumably. We also need that up here. rs untrusted token. And now we verify it, turning it into a trusted token. So we take the key, we take the untrusted token, we take the validation rules, and a bunch of other stuff. And now probably this thing, this has to, so let's write ABC here. And now I think it should fail. And it didn't even compile. Because this has to be in some token. Yeah, so it panicked on the unwrap, which is because this thing, which is some kind of implicit assertion, whatever that means, it was not set. So if we set it to ABC as well, now it works. If we set this to CBA, it panics. So it has to be the same. So we do that. So once we get a token verified, we can check out the claims in the token. So payload claims, and let's unwrap that. And let's run it. So there's a bit of noise now. Let's get rid of that. So now you can see the claims are some expiration, the data, and the user ID. So once you get a token like this, you probably check, is it expired? And if it's not, then you can check on the user, their access rights, and so on. Right. So maybe one last thing we want to change is the expiration date. So how can we do that? Expiration. Okay, so we can say claims expiration, and I don't want to use chrono right now, so let's say it's gonna be whatever the string they have there. So now if we run it, the expiration is 2039. So this is one way you can let a login session be long-lived. Probably you should not set it to too long because the encryption has some lifetime. Most encryption probably has thousands of years, if not lifetime of the universe with current computers. But it shouldn't be too long, this expiration. Okay, so IADIS issued that. Okay, I think that's it. So now we kind of like figured out how this token stuff works. And yeah, that is it. Maybe just let's do something like this. So generate a symmetric key. Generate symmetric key. Let's do that. Because basically I want to generate this kind of thing in an automatic way. So we need this stuff. And here is just the key, which will just print out. And we need the symmetric key like that. Don't need generate, it seems. Do need v4. And then we actually do need generate, I just didn't realize it before. What? So we also need this formatting thing. So now we can run cargo, run bin, generate symmetric key, and you can get something out there that you can use, and that is secret and unique. So that's it. In the next video, let's try to make some login form and get like the login flow up and running. So see you then. Bye bye.